Okay, this is strictly a setup for the next lesson. So you got three parts here. Determine whether the ordered pair is a solution to the linear inequality. I did not give you sufficient workspace here. You need to take that and just copy it, okay? Just copy it down. You don't have to do that on the others, but I did not give you enough workspace. Here is what you do. You circle that sign, okay? And you circle each side. Put a big circle on each side, the whole thing, the whole shebang, okay? Now you label that X, Y. So you scribble out that Y and you put 0, okay, in it. So I don't got to do nothing there. I drop the sign down and I've got 0. Now on the other side, I need to put 0 in for X. So I put a 0 there and I put a times dot so I know that's multiplication. So I take negative 2 ABC5 times 0 plus 4. I got 4. Now here's my question to you. Does the sign eat the bigger number? 4 is the bigger number. The sign is not eating that, so that answer is no. Okay. Next problem. Now we got workspace, so we're good. Circle the symbol. There's only going to be one of them. Circle each side of the symbol. Okay. And we are going to put that in for my variables. Okay. So Y, I scribble Y out and put 1. Okay. So that means 3 times 1, that's 3. Now over here, okay, X, get rid of your X and put negative 6 in. If you want to make that plus negative, you can. So now I do the operation. 5 times negative 6 plus negative 12. I got negative 42. Now I have a positive is always bigger than a negative, okay? So that's a bigger number. Circle the bigger number, and the sign does eat that number, so that is a yes. Okay. Now, next problem. Circle the symbol, and then circle what's on each side, just like that. So Y is negative 7, so you scribble out the Y and put negative 7. You don't have anything there to do, so negative 7 is the value on that side. Now over on the other side, we scribble out X and put negative 3. Now there's no times because there wasn't a number in front of it, but it's plus negative 3. So I go negative 3 plus negative 3, it's negative 6. Now, when we have two negatives, the smaller negative is actually bigger, okay? Like it goes opposite when there's two negatives. So the bigger number's there. Does it eat that number? No. Okay, so that is a no. Okay, next circle the symbol and circle each side of the inequality. So 3, 6. So Y is going to be replaced with 6. So that side, there's no operations, it's just a 6. Don't put a 1 in front of it. If it doesn't have a number in front, you don't times. Then 3, and this means 2/3 times 3 now, plus 4. So I go 2ABC3 times 3, and then I add 4. That's 6. Now they are the same number. If they are the same number, we check to see if the line's there. It's there, that's a yes. If it's not there, it's a no. Now what you need to do now is pause your video and do 1 through 4 and then resume it when you're done with through 4. Now, in your example packet, go to the graph. Skip that next page, go to the graph, okay? Now, we're going to represent all of the yes solutions. You're like, well, how the heck do you do that? Well, here's how. I've got the line down. I mean MB, you'd have 5, then down 2 over 1. You don't have to worry about that, okay? So, circle each side. Now I need to pick any point on the graph, but it can't be on the line. It cannot be on the line, okay? I will go over 3, over 4, up 2, right 4, up 2. But you got to label that point then correctly. You pick your own point. It can be anywhere. It just can't be on the line, okay? If you want to stay in this little section here, then you'll only have positives. So x, this is x. So 0, 1, 2, 3, 4. So x is positive 4. And then up on the y-axis, 1, 2. Okay? Now you do what you just did on the last problem. Okay? Be careful. So y is 2. So on that side I will just have 2. Then x is 4, so I put a times dot and replace cx with 4. So I figure out what negative 2 times 4 plus 5 is. It's negative 3. A positive is always bigger than a negative, but it's not eating the correct number, so that's a no. So here's what you do after that. Over that point that I just picked, put a big no. That means every point over here on this side, here's the line, any point on that side is a no. Any point on the other side is a yes. Okay? So, there you go. No, yes. You got to decide which side of that line has a no, which side of the line has a yes. Okay, next one. Y is greater than 2x minus 1. There's your line. Don't worry why it's dashed. I'll explain that in the next part, okay? But there's the line. The line separates the no's from the yes in an inequality. You got to figure out what side's what, okay? So, circle, circle. Okay, find a point somewhere. Could be anywhere. As long as it's, I'll go forward 5, up 2. How about that? Okay, that works. So on the x-axis, I went 0, 1, 2. To the right's positive. And then on the y, 0, 1, 2. So 2. So y is 2. When you're doing this on your own, you pick any point as long as it's not on the line. X is 5. So this side there are no operations, we just have the number 2. On this side we go 2 times 5 minus 1, that's 9. They're both positive, it's obvious 9's bigger, but the sign is not eating that, that is a no. Okay? So put a no, and on the other side we put a yes. Okay? No, yes. Every point, any point over here would have been a yes, any point over there would have been a no. Okay, there's the line. Looks like complete crap, but that's none of your concern here today. Okay, so pick a point. Okay, this is a much shorter one because we just have a y and a negative 2. Okay, find a point. I'll go, heck, what the heck, I'll go forward 2, up 6. So 1, 1, 2, 3, 4, 5, 6. As long as it ain't on a line, it's good. Okay, it's a good point. So what is that point? You got to know what the point is. So on x, 0, 1, 2. So 2 is x. Then on y, 1, 2, 3, 4, 5, 6. So 2, 6. Now you scribble out your y and put 6. If you don't see x there, you're missing x. Who cares? Okay? So you don't scribble out x if it ain't there. So we have just a 6 on that side, and we just have a negative 2 on the other. If you want to put plus negative, fine. You don't really need to. A positive is always bigger than a negative. It should eat that number. It does not, so that's a no. So I'm on a losing streak here, but that's fine. Because this line, that's no, so go to the other side of the line you see, and that's a yes. Okay, last one of these. So I need to find replacements for x and y. Okay. See, you don't have to go here. You can go back if you want. You can go back 4, left 4, because on x, left 4, and down 3. What the heck? Okay. So on the x, you're at -1, -2, -3, -4. So x is -4. Then the y, -1, -2, -3. It doesn't matter where you pick it as long as it's not on the line. Different people will pick different things. So scribble out the y and put -3. Scribble, put a times dot to separate the 3 from the x, and then you're putting -4 in. So on this side I have -3. On the other side I need to go 3 times -4 minus 5. Got -17. Now if I have two negatives, the smaller the negative, the smaller negative is bigger. So that's a yes, it eats that. So this point is yes, and the other side of the line is no. Okay. Pause the video now and do 7, 5, 6, 7, and 8. Then resume it and I'll show you how to do the last part. Okay. Okay, now for the last part. Find this in your note packet. Rewrite in slope-intercept form. Rewrite in slope-intercept form. We've done this before, but never with a greater than or less than sign. So you make a wall, you got to get the y by itself, okay? You can put a 1 there, and it's multiplied by 1. So it's +1, so we put a check mark, that's good. So I don't do the opposite thing, okay? So you have a -3x, so you add 3x, but we need to create our x there of 0x. So line up your symbol, 1 times y. So we do our x's first, 3x plus the 5. Now divide all your crap by 1. Don't put equals, you put the inequality. So it's y, 3x plus 5, okay? Now we're good, you got m and b right there. Y, mx, b. Now, here's the kicker here today. You got to remember this, okay? So 1, make it plus negative, so y is a -1 multiplier. Now remember, you don't want that negative, okay? So you apply the opposite rule, but here's the kicker. It's not just an equals. So when I go through here and apply the opposite rule, +6 goes to -6, -1 to +1, and that sign has to flip, okay? See, I didn't do it there because I didn't have to do the opposite rule, but now I do. +5 goes to -5, so the sign also has to flip. Now it will not flip anymore. So plus 6x, make a 0x and plus 6x there. So line up your new symbol, 1 times y, you're going to get 6x plus -5. Then you divide everything by 1. And you're dividing everything by positive now, which is why you make that positive. So now you're going to get 6x plus -5. If it's a decimal, you leave it as a fraction. Okay, m, b. Okay, next one, wall. The y is what you dot and circle. And it's positive, so we do not do the opposite rule. That means don't flip the sign. Okay, apply a 1, minus 1x, make a 0x and minus 1x there. So don't put equals, you line up the symbol. 4 times y, figure your x out first, it's -1x, and then plus the 20. Now I divide everything by 4. Well, I don't just put equals. I know you're used to that, but you got to break that habit now. decimal, so guess what? I'm leaving it as a fraction. And then 20 divided by 4 is not a decimal, it's 5, so we have M and B. Okay, then our last one, negative 3x plus y is greater than or equal to 6. Okay, so here's your y, it's got a 1, it's positive, check it. Okay, so no, don't need to do the opposite rule. Okay, so that means the sign also doesn't flip. If you have to do opposite rule, you got to flip the symbol. The line would stay, line stays. Okay, if you do flip it, the line still stays there. Plus 0x, then plus 3x. So we have 1 times y, that's 3x plus 6. Okay, divide everything by 1. Okay. 3 divided by 1 is 3x plus 6. Okay. Now,